Hi there. I'm Phillips. I've had the privilege of working for Roke Research, a research and development organisation, for over 30 years. During that time, I've been involved in a number of developments, as you might imagine, and through those developments have had to deal with the issues of security and how you go about developing secure products. What I'd like to do today is share with you a little bit of that experience, and in particular share with you how a more enlightened approach, if you like, to security, and in particular integrating together security and engineering teams, can produce a far more effective result, and a result that's necessary in today's cyber world. So often, even today, I come across with engineers, particularly from different companies, the view that information assurance is not so much necessary as actually obstructing what they want to do, that it comes in late to the exercise, it comes in restricting what the engineers and what the business developers want to achieve, and seen really as disrupting the whole process. But we've heard from various speakers today that the cyber threat is growing, it's massive, and the need for information security in products has never been greater. And so, like all good security activities, there's a real need for good cooperation between all the experts involved in the activity, in this case, product research and development. And so, I'd like to try and show you at a very high level some of the things we've done that have made that process not only a lot easier, but a lot more effective as well. So the diagram I've got here really is a very simple diagram. The concepts that are there are probably familiar to many of you. The basic approach to security analysis. Understanding what a system is, understanding the environment it's in. Then understanding what you want to protect and why. The vulnerabilities you face, the impacts of those vulnerabilities, and then conducting a risk assessment as to which you need to protect the most. And then finally putting in place the controls to provide that necessary protection. Very simple overview of the process. But the trouble is, traditionally, that's often been applied very late in the development cycle, where it actually tends to point out what in the development perhaps a developer shouldn't be doing, rather than pointing out what they should be doing. And so what we've done more recently is when we come into a research and development project, either internally or quite often for other companies, other organizations, is we bring that process in early. And what we find is, if we sit down with the business people, those who know what the product is trying to do, the benefits they're trying to get, and the engineers, what we find is they've got a pretty good idea of what it is in principle they're going to build. They may not know exactly what it looks like, but they typically know the types of things they're going to use. They know the types of ways they're going to put it together. You can actually start to come up with that architecture. And by a very early security analysis, you can start to set security objectives for whatever it is they're developing. Then, through that process, it means you can bring the engineers in to work to meet those security objectives. And at the end of the day, they're probably the people who are best placed to work out how to meet those security objectives, because they understand the technology they're working with, and you're also working with the business people who understand what the product's got to do. It sounds like a very simple, obvious thing to do, that you bring security requirements in like any other requirement early in that engineering process. But very often, even today, I come across circumstances where that doesn't happen. I see project plans where the analysis of security and decisions on security really occur far too late in the engineering life cycle. So, to give you one example at a very high level, we were recently involved in some research and development around avionics. We've heard today very much about how security and safety are tightly coupled together, and that's particularly true in avionics. A lot of historic avionics architectures are based around individual bespoke systems put together in a fixed architecture, and then going through, as you would expect, a strong approvals, safety and process, and more lately, a security process as well. The big problem aircraft manufacturers face is it's very expensive to make changes to that then. To replace technology forces you back through an approval cycle. And that runs contrary to the benefits that we see with modern technology, the Moore's law, where faster, more capable processors are coming along all the time. Yet for them to grasp that benefit is a very expensive process for them. So we worked with one organisation where the challenge was they wanted to move to a set of effectively generic processors upon which they could host different applications. They recognised the need for security early, and we worked with them, both with people who are expert in what the avionics had to do, as well as the kinds of technology that they would use to implement this generic architecture. And from that, we were able to build a security architecture, we were able to analyse the threats, and we came up with a set of security objectives that their engineers could then consider and actually work to meet. And it generated a very positive process for this. And it meant security ceased to be an afterthought. It very much became an enabler of that technology and enabled the technology to move forward with security by default, as was mentioned earlier. And so from that, it showed that this was one example of new technology where you could work with people to get an early view of that technology and build the security in earlier. And we've actually done this on a number of other areas as well. And it does seem to work well. But fundamentally, the call I'm making is to move away from the old historic view and historic way of working with information assurance, whereby it was almost a post-design exercise, to being integrated early in the design process and to work proactively with the business and engineers, such that in a way it becomes a force multiplier for security, something that's needed in today's connected world. And so this diagram just gives a very quick summary of the kinds of things against that simple process. So we work with people to understand the business, the application, the environment. We bring in cybersecurity expertise to work to understand the threat from the environment and to work with the business people and the engineers. Working our way down to the fact the expertise in leading edge technologies can be brought together to land up with a solution which is not only business relevant but security relevant as well. So that kind of gives a summary of the approach that we've been pursuing now for several years and which has worked very well. And I would kind of make the appeal that going forward, particularly with IoT SF very much connected, that process of bringing the security expertise into the design community early will not only enhance the security but help underpin a lot of the other work we've heard about, for example, from IBM for the security framework. And that then kind of leads me on to, well, kind of what next? So we've heard from John that IoTSF have published a framework. There are other frameworks out there and guidance. And again, my appeal for this really is with the frameworks, and we've seen parallels with this with, for example, some of the government security, the good practice guidance that comes out from UK government, that within that, the frameworks can provide a structure which mirrors this kind of activity, which prompts people and organisations to work with that kind of activity. And what we've seen, one of the things we do at Roke Manor is we provide product assurance services. And we've seen guidance on that shift over the last few years away from very detailed specific guidance, for example, about specific versions of operating systems, more back towards what are the objectives of that guidance, and for the companies and suppliers work with that guidance. So that kind of gives me the view, the suggestion then, that I look forward to frameworks supporting and sort of underpinning this activity. And that's really kind of it from me on that subject, but it really is to say bringing security in early to that design process really can work, even at the point at which you've got emerging technologies where the final product is not clear. Okay, thank you.